Big Data tutorial with AWS. Let us first review what we are going to demo. We will create a crawler to crawl data in S3 and create metadata in Glue Data Catalog database. Next, we will query data in S3 using Athena. After that, create a Glue job to transform CSV data to Parquet format. Post that, we will query S3 data with Redshift Spectrum. Next, we query Postgres data from Redshift using Federated Query. Then we query data in S3, Postgres, and Redshift together by joining them. And finally, we will create our reports in QuickSight by fetching data from these data sources. To begin with, let's set up our S3 bucket and data. We are in AWS console, Amazon S3 section. Here we have a bucket called Auto Company, which has two subdirectories, ingest and processed. So under ingest, we have cars and trucks subdirectories, and under cars, we have cars.csv. And similarly, under trucks, we have trucks.csv. The processed directory is empty. Let us look at the CSV files. So this is cars.csv. It has information about cars. It has various columns like name, MPG cylinders, and so on. And this is trucks.csv. It has similar columns and it has information about trucks. We will look at Glue Data Catalog and crawlers next. A data catalog is metadata of your data. It exists in the form of tables in data catalog database. It has metadata information like schema, location, etc. of your data, while crawlers create this metadata by crawling or examining your data sources. We are in AWS Glue console now. Let's choose the database option and hit add database. Let's give this database a name, Auto Company DB. Hit create database and our database is ready. Now we should create a crawler next. Let's choose that option of crawlers and hit create crawler. Let's give it a name, Auto Company crawler. Next, okay, let's add a data source. So that's S3, right? And provide a path to our cars directory under the ingest bucket. Add the source, data source. Let's add another data source, again S3, and this time pointing to the trucks directory. Okay, let's add that. So we have created these two data sources. Hit next. Let's create a IAM role for this. Okay. Now we can hit next. Use our target database. This is the same database we created earlier. Our crawler will run on demand. Okay. Next, right? So review and create. Let's run the crawler now. Okay, let's select the crawler and hit run. So we will wait for the crawler to finish, and it has completed successfully, and you can see that it has created two tables. So let's go under database tables, and here we see that it has created two tables, cars and trucks. So let's look at that. Under trucks table, here we can see the schema. It has all those columns that we have seen earlier, right? So you can hit edit, and you can even edit the schema here, right? Now we can query our data in S3 using Athena. Athena is a serverless query service that allows us to analyze data directly in S3 using SQL. We are in AWS console in Amazon Athena section. So let's explore the query editor. Here you will be prompted to set up the query result location in S3. Hit edit settings and provide location of your query result. Hit save. Let's go back to the editor. Make sure our data source and database are correct. Database is same as what we created earlier in Glue Data Catalog. Okay, let's write our SQL query. Select some columns from our cars table. Run. Okay, we can see the result here with those two columns. The same result we will also see in our S3 target location. So let's check that. So we are in S3 here now, looking at target location. Let's refresh that. We see some new subdirectories. They follow the pattern of year, month, day, and within that you have the CSV files. Let's download the CSV file. Download, and let's wait for that. Okay, waiting for download to complete, and now we can open the file. So that's our result as per our SQL query. Let's see how to create a simple glue job to transform CSV data to Parquet format. In AWS console, we are in the AWS Glue Studio section. Here we select the job section and we select the first option to create our job visually. Our source and target is S3. Okay. So we can hit create. So on this visual canvas, you see many options like actions, targets, and so on, right? And three nodes have been automatically created for us. So we select the first node and go under data source properties section. And here our S3 data source type is data catalog table and our database is auto company DB, right? And our table is cars. Okay, then we hit the transform section, right? So under the transform section, we can change the name of our columns and so on, or even drop columns. Okay, and let's select the data target node, and here let's select the format as Parquet, which is a query efficient format, and compression type as gzip. Okay, and we need to provide our S3 target location. So let's give that as our processed directory on S3. Okay, and let's provide this job a name. Let's call it auto company John and hit save. Okay, we have an error under job details section. We need to select the IAM role. Okay, so let's select the role we have seen earlier. Okay, we will review this role under IAM roles console. Here under permission policies, let's expand the first policy, and under the resource section, make sure that we are providing access to all the directories that we need. Okay, this looks good. Let's go back to our glue job. Other properties like type, glue version, and so on, we leave as default and hit save. So the job saves successfully this time. Before we run the job, in S3, we make sure that our target process directory is empty for the demo. Okay, back to the glue job, and now we can run it. So let's hit run. So the status is running, and let's wait for it to complete. All right, so the run status has changed to succeeded. So in S3 target location, we should see the output file, and there we have it, a Parquet JSON file. Okay. Back to the glue job, let's quickly review the code that was generated for this job. So this is the script that was generated and executed. You could download the script and use it as a starting point for your more complex jobs. In the script, you can see those nodes we have seen in the visual editor earlier. Okay, so that's all about the job. Next, we will query S3 data using Redshift Spectrum. So let us set up Redshift first. In AWS console, we are in Amazon Redshift section and we will be using Redshift serverless. So let's select that. And here we will use default settings. Okay, our default database name is dev. We will associate IAM role later. Okay, and now we can save configuration. So let's wait for the setup to complete. The setup is complete and we are now in the dashboard. Here we can see we have a default namespace and default workgroup. Let's select the default namespace, and under security and encryption section, we want to associate an IAM role. So let's select manage IAM roles. But first we need to create this IAM role. For this, let's go to AWS console IAM roles create role section. Choose entity type as AWS service, use case as Redshift, and under that Redshift customizable. Hit next. Let's add some permission policies. So Amazon S3 read-only access, and AWS Glue console full access. Hit next. We could make these policies more restrictive. However, this will do for now. Let's provide a name for this role. We'll call it Redshift Role Auto Company. Okay, now we can hit create role, and our role is ready. Now we go back to Redshift and associate this newly created role. Okay, and save changes. So our role is being added, and now we are ready. Let's query S3 data now using Redshift Spectrum. In the dashboard, let's select the query data option. This will take us to the query editor. Okay, and we will create an external schema now using this query from data catalog, and schema name is Spectrum. It could be any other name. Database is AutoCompany DB, and that's the ARN of the IAM role that we have seen earlier, Redshift role AutoCompany. Okay, now we are ready to run this query now. So that executed successfully and our external schema is created. And now we can run a query to fetch data. So let's do select star from schema name dot table. Let's run that. And we have the results. These results are coming from S3. So here on the left hand side, if we expand the database, we can see the schema that we created, and it shows the tables under it that are available for query. Just like we queried S3 from Redshift, we can also query other databases like Postgres using federated queries. So for this, let us create a Postgres database first. In AWS console, we are in the Amazon RDS section and we choose create database. Under engine options, we'll use Amazon Aurora and edition will be Amazon Aurora Postgres compatible edition. Let's choose a version. We will select the 11.13 version. This version has been chosen because it will allow us to use the query editor option available via RDS. And this will be a dev test instance. Let's give this cluster a name. We'll call it AutoDB cluster. And let's provide a master password. Confirm the same. DB instance class as serverless. Leave that as serverless v1. Okay. Let's reduce the maximum capacity. Okay. So the connectivity part, we leave all that as default. It's going to use default VPC. All right. So let's quickly review the settings. So we don't really need that. So here under connectivity, additional configuration, we must enable the data API if we plan to use the online query editor. Okay, now let's create database. So the status is creating now. Remember, if you already have a database of your own, you could use that instead. So our database is ready. Let's choose query editor on the left hand side and here select the database instance and provide a username and password. And the name of the default database. Connect. All right, so now we are connected to it. So let's create another database here for our use. Let's call it AutoDB. Create database AutoDB. Run that. Okay, good. So that's successful. Now let's change to that DB. Select the change database option. Okay, so again connecting to the database, and this time we provide our database name as AutoDB. Connect to that database. Okay. Now here, let us create a table for our use. So let's create a table called trucks underscore size. It only has two columns, name and size. Okay. So that executed successfully. Let's add some data to this table, trucks underscore size. We are adding some truck names and sizes. Right? So we'll add a few records. So let's execute that SQL, run. Okay, so that ran successfully. Great. So now we can query this data. So we should be able to select this data from Postgres very easily as we are directly connected to it via our query editor. So select star from trucks underscore size, run that, and there you see we have the data, name and size. Now let us create external schema in Redshift to query Postgres using federated queries. We are in the Redshift query editor now, and here we have seen the spectrum schema earlier. Okay. Now it's time to create a new external schema from Postgres. Right. So we'll call this schema Postgres underscore auto, and we need to provide all of those information. Database is AutoDB that we have seen earlier. Schema is public. We need to provide the URI to the database. So we go back to Amazon RDS, choose our database cluster, and under connectivity and security, we copy the endpoint. That's the URI. We are back to Redshift query editor, and we paste that here under URI. Okay, and we need to provide IAM role. So this is the role we have seen earlier, Redshift role auto company. Let's review its permissions and policies. So we need to add a new permission here. Attach policies. So we will add secrets manager read write. Attach that policy. We need this so that Redshift can get information from the secrets manager. Okay, so we are all set here. Let's copy the ARN here of this role. Okay, and let's paste that ARN against IAM role. Okay, we are in the AWS secrets manager section, and here let's take a look at the secret names. So when Postgres database was created, a secret was created here. So let's click on that and take a look. So that's the RDS database Postgres credentials for AutoDB cluster. Okay, uh, let's copy the secret ARN. That's what we need. Okay, back to Redshift query editor, and let's paste the secret here, the secret ARN. All right, now we can execute this SQL. Let's run that, and that's successfully executed. So here on the left hand side, let's refresh the dev node, and here we can see the external schema Postgres auto, and if we expand that, we can see the table name trucks underscore size. Next, let us query S3, Postgres, and Redshift individually and then together by joining them. Okay, we are in the Redshift query editor, and let us write a query to fetch data from Postgres. So we use the schema Postgres underscore auto. Right? So select star from Postgres underscore auto dot trucks underscore size. Okay, so let's execute that query. We are running it, and here we are able to fetch the data from Postgres. Okay, so here on the left hand side, if we expand the spectrum schema, the external schema, we can see the cars and trucks tables. Now let's try to fetch data from that. Select star from spectrum.trucks. Okay, so yeah, we are able to get data from S3. Okay, now let's write a query to join and fetch data from S3 and Postgres together. So you can look at the from clause. It uses spectrum.trucks and Postgres underscore auto dot trucks underscore size, and it is joined using name. Right. So let's execute this query. And in the result, you can see the name and cylinders is fetched from S3, while the size information is coming from Postgres. Okay, let's create a table in Redshift, right? So we'll call this table trucks underscore capacity, and it has two columns, name and capacity. Let's run that. So the table is created under the public schema in Redshift. Now We will add some data to this table, trucks underscore capacity. So a bunch of insert statements, right, which will have truck name and capacity information. Let's run that. Okay, that query executed successfully. Let's write an query to fetch data from trucks underscore capacity. So we should be able to get this data quickly from Redshift. So select star from trucks underscore capacity. There you have the result. Okay, now let's write an SQL query to fetch data from S3, Postgres, and Redshift tables together and join them. So in the from clause, you can see spectrum.trucks, Postgres underscore auto dot trucks underscore size, and trucks underscore capacity. These are all joined using the name column. So let's run this query. And here we have the result. Name and cylinders is coming from S3, size from Postgres, and capacity from Redshift. Next, we will create a materialized view using the federated query we just wrote. A materialized view is a kind of view that caches the result of its SQL query until it is refreshed again. We will use this materialized view to populate the data sets in QuickSight later. So here we will write our query to create the materialized view. Essentially create materialized view mv underscore trucks as and the query we have seen before. So let's execute this. Okay, run. So our materialized view has been created. Okay. Let's select from this view. So we'll do a select star from mv underscore trucks. So that fetches the data as per the query of the view. Now remember that this is a materialized view, so it will cache the results. However, you can refresh the materialized view to execute the underlying query again and to cache the latest results. So let's execute that query. Okay, there is a slight mistake there. So refresh materialized view mv underscore trucks. Let's run that. And the view has been refreshed. Now if we select from mv underscore truck, we get the result from the cache. And you can find the view listed here under public schema views. Next, let's make sure that QuickSight can reach Redshift. We need to make our Redshift database accessible to QuickSight. So under Redshift workgroup configuration, under data access, network and security, publicly accessible configuration is set to on for the purpose of our demo. Now we can create reports in QuickSight. However, before that, make sure that you have created an account with QuickSight. We are using QuickSight Standard Edition and we are in the dashboard. So let's select the datasets option here and create a new dataset. We'll select Redshift Manual Connect and let's give it a data source name. We'll call it DS Redshift Auto, connection type public. Okay, and we'll go to Redshift dashboard. Under the default workgroup, let's pick up connection information from endpoint. So let's copy that uh, entire endpoint and go back to QuickSight data source configuration. Let's paste that here and remove the port and database name part. So that's the database server. Let's put the port here and database name. Add username and password. If you're not sure of the database credentials, you can go back to Redshift dashboard and set it there. Okay. So now we have all the information ready, and let's hit validate. Okay, so that's successfully validated. Hit create data source, and here it shows all the schemas from Redshift. So we select public, and under tables we select mv underscore trucks view. Select that, leave that as default, and we can hit visualize. Okay, so our data set should have been imported. Let's view our data set by selecting the datasets option. Hit that mv underscore trucks, and under that edit dataset. Now here you should be able to see the dataset that has been imported. So this dataset has been fetched from mv underscore trucks view. Okay, so let's go back to the dashboard and choose the analyze option. Select that. And by selecting columns on the left, you can create various kinds of visualizations. So here we select a name and cylinder, and we have this kind of graph. Let's add another sheet, and let's select size and cylinder, and you have another kind of visualization. Let's add another sheet and choose the visual type as table, and let's select some columns. So with that, we come to the end of the AWS Big Data demo.